Hi, this is Kalori. Welcome to Scrum and Agile Digest. Let's continue on with calculating team velocity and task breakdown. So, what I forgot to mention here is that it's a 2 week sprint, right? So, by 2 week, I mean 10 working days. So, what's happening here is that we assume that all of these 5 team members are fully committed to the 2 week sprint. Okay. And I assume, that they're probably going to work 5 to 6 hours, or some are working 4 hours every day on this particular user story. So given that in 10 days, the total capacity that I have for all the 5 members is the top row, right? So Harry has 50, Ferris has 50 hours, Neo has 40 hours, Forrest has 40 hours, Katniss has 50 hours. They can actually work. Now, what you need to do is you have to find out the committed capacity, right? Now, committed capacity is basically what we got from the previous table, right? So if I go back to the previous table, you can see here, this is what the team members are ready to commit. So Harry is 32, Ferris 29, Neo 10, Forrest 13, and Katniss 29. So that's what I have here in the second row. That's the committed capacity. So based on that, you can get the available capacity, right? That is the total capacity minus the committed capacity, right? So the available capacity that I have left for the team members after the finish story 1 is available capacity. So Harry has 18, Ferris has 21, Neo has 30, Forrest has 27, and Katniss has 21. So this is how you will find the available capacity for your team members if they are available to pick up any other story or not. And you can also find out the task breakdown in percentage. It's equal to the committed capacity divided by the actual capacity. And you can get that in the percentage. So right now the task breakdown percentage is 64% for Harry, 58% for Ferris, and so on. So basically, this is how much they are already committed, right, in the particular sprint. So you can do this after every story and try to find out how much available capacity each team member has, and accordingly you can allocate stories. And in Excel, it obviously makes it very difficult, but with Jira, it's so easy. You feed the numbers, it will automatically calculate, give you the available capacity, and it makes things very easy for the Scrum Master during the sprint planning meeting to see how much capacity the other team members have, and if they can pick up new stories or not. Now let's talk about scope change, right? We already said that in Scrum we welcome change, right? So scope can change during the story. So you might be adding new story points, you might be de-scoping, you might be taking out story points, and that can definitely affect the velocity of the team. So if I look at the table here, let's say I add three stories in sprint 3, right, for 5 points each. So let's say in sprint 3 I added 5 extra points, story points, and then in sprint 4, let's say I add 2 stories of 5 points each, which is 10 points. Right? If similarly, I can de-scope, right? Let's say in sprint 5, de-scoping, I took away 1 story of 5 points, and then in sprint 6, I took away 2 stories of 5 points. So I took away 10 points worth of story in sprint 6, 5 point worth of story in sprint 5. I added 15 points worth of story in sprint 3, basically 5 points each, 3 stories are added. In sprint 4, I added 2 stories, 5 points each, so 10 story points. And now that can also affect your sprint. So based on how many stories you added or took away, you can basically see the percentage of story increased or descoped. And again, this is a metric, you may or may not use it. I'm just giving you the whole, the whole bag of metrics. You can pick and choose whichever you want is best for your team. And actually, the first column is the committed story. So initially, this is what you started with, right, during the sprint planning. So sprint 1 had 20, sprint 2 had 21, and then you added some stories during the sprint, or you took away some stories, and now you can calculate how many stories can be in the increased percentage of the descoped. So the descoped is basically equal to the descoped stories divided by the committed story point into 100, and the added stories in the same way is the added stories divided by the committed stories into 100. This way you can find out the increased or descoped percentage, and if the stakeholder, product owner, let's say, is looking for this metric, you can show them. It also shows you how the sprint is progressing. It's a good metric to have in your bag. So for example, in sprint 1 and sprint 2, you can see that no change was there, so it's 0% increase or decrease. In sprint 3, we added stories, so basically the scope increased 68%, and then sprint 4, we added 10 story points, it increased 33%, and similarly in sprint 5, we descoped it, the stories decreased to 38.46% approximately, and sprint 6, it's decreased by 83.33%. So if you want to chart the descoping and adding with a variance, with respect to variance, you can do that. So if you look at the previous table, this was my increased or descoped story points. I chart this as a variance here. So basically sprint 1, sprint 2, 0%. Then we added some stories in sprint 3, it went to 68%. And then basically I added some stories in sprint 4, 33%. Then basically I took away some stories. So there's a variance here. Basically the variance will show that there was some changes made to your story points. So this is a good way to show that basically scope changed, right? Now the ideal variance should be 0, right? That you should not make any changes to your stories once the sprint has kicked off. It should be 0. But sometimes, usually, especially during when your team is new, the process is new, you might be adding or removing stories, so you might have some variance. But as your team becomes more mature, your variance basically will usually stick to 0%. So basically you're not making any changes to your sprint. You're not adding any stories, you're not removing any stories. And that's a good measure to see how mature your team is. All right. Next thing I wanted to talk about was defect leakage. This actually means it's a good metric. It actually shows how many defects you are generating throughout your sprint lifecycle, right? So during my sprint lifecycle, I'll have multiple tests, right? I'll have regression, functional, load testing, integration testing. You need to see how many defects are found at the end of the sprint lifecycle. Like, you might have UAT, user acceptance test. So you want to see basically how many defects are leaking out, right? Now, lower the number of defect leakage, the better it is. And I want to show you a table that will explain the concept better.